Okay, so my name is Shihan Fu, and I am the first author for the essay A Machine Armed to Assist in Trash Sorting using Machine Learning and Object Detection. So the main issue that I'm trying to solve with my proposed solution is the issue of improper recycling. So improper recycling itself is a large issue, and then the issue itself is actually causing more issues, such as uh the fact that 80% of the trash that are in landfill are actually recyclable, and then due to this, a lot of recyclable resources are actually going to waste. So instead of reusing the ones that were already made, it's actually forcing us to spend more money and more materials to remake those things that we thrown away. And then also the greenhouse gases that were released in landfills are also the main cause of global warming. And then these are like the issues that are harming our environment. And then improper recycling could also cause harm directly on human beings. So the trash that we throw into like random places, like places where it shouldn't be thrown at, like oceans or like lakes, that could like get back to our bodies by breathing and ingestion. So the larger piece of plastic we throw into water can be broken down by the environment or by animals themselves. And then once they're like broken down into microplastics, it could get into our body and it could cause inflammation and tissue damage. And then when a certain amount of microplastic actually accumulates in the bloodstream, it could clog up the vessels and basically lead us to like death. Um And then the like issue of improper recycling sounds like a really like vague issue that like everyone's trying to solve and then like no one could really solve it. But once you like break it down into like smaller pieces, it's actually like more tangible. So improper recycling is basically caused by lack of knowledge in recycling, contamination, and the fact that people think it's too time consuming. So according to research, only 29% of Americans say that they're confident about like what to recycle and what not to recycle. And then the stuff that we put into the recycling bin, those trash like 25% to 30% of them are actually contaminated, which means that they cannot be recycled anymore. And then a lot of people state that they think recycling is too time consuming, and 44% of Americans basically said that recycling is like inconvenient for them, and then they don't do it because it costs them too much time. And then the approach that I'm taking is basically implementing technology like computer vision and robotics streamlines and automates the recycling process. This is basically meant to like reduce the errors and inefficiencies associated with human sorting or recycling. And then for my for my solution can basically put the trash like in front of a camera, and then the machine learning model will decide like for us human beings like what is recyclable and what isn't recyclable, so like the chance of human errors isn't like there anymore. And then it's also more cost efficiency because it basically reduces the chance of like contamination and like causing like recyclable stuff to become non-recyclable. And last, it also like it is able to handle like hazardous waste such as like the ones that have like radiation or whatever, because like human beings can get affected by those, and but like machines they can't like get cancer or something from like radiation. And this is the demo video for my solution.
Yeah, okay. So one, you want to put the this one first?
I'm gonna see something for the card.
This was it gets loose.
So as you can tell, the plastic water bottle was put in front of the camera, and then after the camera made its decision, the robotics arm basically turn and sweep the trash into the recycling bin because like plastic is recyclable. And then aluminum was also being like swept into the recyclable bin because the the aluminum can basically be like melted and then like be made into like something else. And the card box was uh thrown into the trash category because as you can tell, like the card box basically had like oil at the edges, which means that it's like contaminated and that it couldn't be recycled anymore. So the solution is basically the like robotics arm had like two parts. It has a Raspberry Pi and a camera that's used for the computer vision and machine learning part. And then there's also a robotics arm that was built using servos with a 3D printed like uh shell holding its shape. And then for the software part, uh the code is written using Python and PyTorch for machine learning and CV2 for computer vision. So overview of the solution. So basically the trash enters that a opening, and then there will be a camera placed like in front of the trash, and then the camera will detect if there's something in front of it, and once it notices that there's a thing in front of it, it would basically take a picture of it, send it to the trash detection model, and then the model will spit out like the name of the trash, such as like a plastic bottle or like aluminum bottle or like fruit peels. And then based on the name that it spits out, we'll look for a keyword. For recyclable, we're looking for plastic and aluminum. And then if those keywords are found, it will basically sweep the trash into the recyclable bin. And then if it's not found, it will be swept into the non-recyclable bin. For the software, it's relied on neural networks for object detection. Basically, the image that's being taken by the camera will be sent into the machine learning model, and then based on the model, it will decide like the name of the trash, and then based on the name, it will be run into like loops to find if it has the keyword we're looking for, and if it does, it's recyclable. If it doesn't have it, it's not recyclable. And this is the screenshot of the code. So in this picture, it detected that there's a plastic bottle placed in front of the camera, and then it draws a square around it, indicating that that's the thing we're trying to find, like the type for, and then it will spits out the name, and then it will go through these loops to find like if it has the keyword we're looking for or if it doesn't. And then for the experiment, we're trying to figure out the accuracy of the model. We have a potential blind spot is how we only tested a like limited amount of items to see if it has like a high accuracy or not. And then we also only tested in an environment where it's like indoors and there's like a white light shining upon it. So we don't know if it will like have the same accuracy under like daylight or like when it's outside and it's like dark. Uh, so this is the data for the experiment. We basically tested like common common items that is likely going to be thrown into the trash can, and then we also tested in daylight artificial light, which is like indoors, and there's like office light shining upon it, and then low light indicating that it's like placed in the park, and then it's like dark outside and there's only like street lights like shining upon it. And then after we did the experiment, we analyzed the data. We found out that the mean accuracy of the model was 70%. The median accuracy was also 70%, aligning with the mean accuracy. And then the lowest accuracy observed was 50%. The highest was 90%. Uh, the model had like the most trouble with glass items with a 40% accuracy. And then we we analyzed the data and then we found a possible reason why it had a lowest accuracy. It might be because because glass is like more reflective than other materials, and then the light that's shining upon it isn't like consistent all the time, so it's having issue with that. And then the model also seemed to have a better accuracy under daylight conditions, meaning that when it's dark and there isn't like much light shining upon it, it's having issue like detecting what kind of item is put in front of it. And then we also tested the ability of the arm because we want our we basically want the project to be placed in like parks so that like any trash could possibly be put in front of it, and then we don't want the like arm be like breaking constantly. So we basically put like heavier objects, taller objects to see if it's able to like sweep the trash into the bins, or like is it gonna break constantly. And then this is the data we basically tested. This is what we started with: a standard plastic bottle, standard aluminum can, and standard cardboard. And then we tested half full water bottles, metal soup can, and then glass jar. Those are the heavier ones. We want to see if it's like heavy enough to break the arm. And then we also tested like taller items to see that if the arm is able to like reach it and then like sweep it correctly into the trash can, or is it gonna like knock it over and then like just like not sweep the trash into the trash can. So basically the mean accuracy rate was 40%. The medium was also 40%, aligning with the mean. The lowest success rate is 0%. It has 0% accuracy for heavier and taller items, meaning that we basically have to for the 3D printed shell that the servers are being held into, we basically have to redesign those and make it stronger so it would be able to knock those items into the trash cans. And we also have a surprising efficiency with smaller and lighter plastic caps, because like before we thought the arm was like too tall for those and it wouldn't be able to knock it into the trash cans. But after our experiment, we found out that the arm is actually able to push the smaller items into the trash cans. So after the our experiments, we basically came up with parts that we need to fix for both the software and the hardware. So currently the limitations for the robotics arm is how it doesn't handle like too heavy, too tall, too bulky items easily. It's having issues pushing it into the trash cans, and it's like breaking at a high rate, and we kind of want to lower that. And then due to the fact that we were basically testing our a machine learning model in like an indoor setting in the office lighting, we we didn't take like real world scenarios into consideration, so it's having issue in areas that's too dark, or it's like not performing as high of an accuracy rate as we want it to. And then to basically enhance our project, we are trying to refine the machine learning model so that it's taking like different lighting into consideration, and it would basically have the about the same accuracy for all lighting, whether it's like outdoor with like really bright like sunlight, or whether it's like placed indoors in like an office setting with a artificial light, or it's like dark outside in the park. We want those to be like working constantly so that people don't have to like worry if like where they're gonna put it at. And now we would also want to like enhance the robotics arm, since we want it to be like put into places like parks, and then we don't want like the arms to be constantly breaking and like having to need people to like constantly come over and fix the arms. We want this to be like a long-term solution to improper recycling. So we want the robotics arm, we want like our whole project to last like as long as possible. So we would want to remodel all those parts to make sure that it could match our it would match our like we it would match how like we imagine it to be. And thank you. That's my presentation.